The first part of the presentation is going to be covered by a colleague of mine, Holly Wild from Source Code Control. So Source Code Control, we help organizations developing software solutions to manage risk in the software supply chain. That risk is both intellectual property and security vulnerabilities. Myself, I'm hosting the webinar, so I'll deal with questions at the end and do this introduction. So I'm director and founder of Source Code Control, and we're joined from Block 64 by James Lipinski, a technical consultant. So Block 64 help organizations manage risk and optimize costs in software within their organizations. So the agenda today, which I briefly started talking about, Holly's going to talk about the context of Log4j. What is it? What does it do? How does it enter into the software supply chain? And talk about the wider security issues of it's not just about Log4j. It's there's many components that developers use when building software, and how do you secure that by design in the future. And the second half, as I said, James is going to give a demo of what Block 64 do to help manage that situation. Now, if you have any questions, please post them in the chat and we'll deal with those questions at the end of the session. So Holly, over to you.
Thank you, Martin. Hello, everyone. So to start the session today, we're going to look at Log4j and provide a bit of context into what makes this vulnerability so serious. That is, as you'll see soon, that is for two reasons. And then we'll move on to looking at some best practices and how to manage software security and looking at the wider issue moving forward. How do organizations manage this? In December 2021, a vulnerability rated as a critical risk in the component named Log4j went public. The vulnerability inside Log4j has been coined Log4 shell. So if you come across this term, Log4 shell is the vulnerability itself that resides in the open source software component Log4j. You'll be familiar with getting updates for Windows and updates to your mobile apps to fix bugs and vulnerabilities. The security issue with Log4j is the exact same scenario. However, this vulnerability is far more serious than, let's say, the run-of-the-mill vulnerability. Log4j, the component, is an open source Java-based Apache logging framework that developers use to keep a record of activity within an application. The open source software creates a built-in log or a record of activity that developers can use to troubleshoot problems or track data within their programs. So you can think of this software as a diary. Its job is to keep a record of how online services and applications are being used. If there is an issue with one of your applications, you can make reference to the logging files that this Log4j framework produces to help solve and troubleshoot the issues. The vulnerability is rated as a 10 out of 10 severity. This is actually the highest severity rating a vulnerability can get. The vulnerability itself enables a remote attacker to take control of a device on the internet if the device is running certain versions of Log4j. And this is the reason why it's been given such a high severity rating. The vulnerability is also relatively simple to take advantage of. This contributes to the 10 out of 10 severity rating also. Within the first 4 days, 840,000 attacks were launched, and some hackers had already developed tools that automatically attempt to exploit the bug. During the first 72 hours after this vulnerability went public, reports documented up to 100 attempted attacks per minute. A high-profile attack deriving from Log4j was launched against one of the largest Vietnamese crypto trading platforms, Onus. Hackers successfully planted backdoors to retrieve sensitive databases before Onus patched their systems. Attackers actually demanded a $5 million ransom, where, however, Onus refused to pay this. Then hackers moved to sell the data online. The reasons for making Log4j the reasons behind why Log4j is so serious is twofold. I mentioned the first one, which stems from its severity. what hackers can do and also how easy they can do it. The second is founded in the fact that Log4j is pretty much everywhere, from big corporations to small to medium businesses. Therefore, this makes the attack surface area and potential quite big. It is everywhere because many pieces of software have logging libraries. It's highly unlikely that organizations, especially the big corporations, are coding their logging software from scratch. There isn't really any benefit to be doing this when there's an open source version available online and it's so easily available. As a popular logging tool, Log4j is used by tens of thousands of software packages and projects across the software industry. Consequently, the Log4j component itself is embedded in a vast array of applications, services, cloud platforms, web applications, email services, and enterprise software tools that are written in Java and used by organizations and individuals around the world. This is the reason why Log4j is so widely used, and Log4 Shell has impacted a very wide range of software and services from many major vendors. We're 2 months on now from when this vulnerability was made public, which was the 21st, I think it was back in early December last year. And this was when it was publicly disclosed and researched. Organizations are still now 2 months on using vulnerable versions. Sonatype, a software company, they're an American software company which conduct a lot of cyber security research, reported that since the 10th of December 2021, when Log4Shell was disclosed, the vulnerable version of Log4j has been downloaded more than 25 million times, even though there is an up-to-date patch version available. And this information was taken from the Sonatype website last week. This really shows the lack of visibility organizations have over their components, the components especially that they're pulling into their solutions. It seems processes are not in place to manage and track versions and the security vulnerabilities associated with those versions. When we think about software security, the key concept is software visibility. If you don't know what is coming into your software, this makes ensuring cyber security very difficult, because if you don't even know what your security problems are, how do you go about fixing them? The Log4Shell vulnerability is a good example of the way attackers can exploit vulnerabilities in popular open source packages and the massive impact that such vulnerabilities can have. Attackers are constantly scanning the internet looking to leverage vulnerabilities and misconfigurations to use for new attack paths. Once detected, the attackers move quickly and take advantage of the time window until the vulnerability is patched and released to the public. Log4j is not the cause of the wider software security issues that we're experiencing at the minute. This is just a symptom of the problem. The effects of Log4j were not the first of their kind, and they're likely not to be the last. Naturally, with the increase in open source code out there in the world, the trend is upwards in relation to vulnerabilities. According to a 2021 report, open source vulnerabilities are increasing at 120% year on year, and breaches are increasing by 55% year on year. Cyber officials have noted that Log4j is one of the most serious vulnerabilities of recent years. That is because of its widespread reach and high-profile attacks. For example, government hacking groups around the world are leveraging the Log4j vulnerability. According to Microsoft, state-sponsored hackers from China, Turkey, Iran, and North Korea started testing and exploiting using Log4j at the back end of last year. The Belgian Ministry of Defence also released a statement saying they were the victim of an attack stemming from Log4j before patches were made. Now we've covered the severity of Log4j, and I've given you some more context to the vulnerability and that there is a need to have visibility of your software to manage these issues. I want to provide some context as to how vulnerabilities like Log4j enter the software supply chain and reside in a final product or service. This is an essential starting point for tracking what is in your software, as you need to know how and when you are pulling it in and consequently pulling in those vulnerabilities. Log4j is an open source component. Open source software is freely available code. It's found in the majority of modern day applications. In fact, it's often the case that modern day software are made up of the majority of modern day software, is made up of open source. A report conducted by Synopsys even found that in 2021, applications contained, on average, over 500 open source components. Developers share and contribute the source code of libraries, components, and frameworks on code sharing sites such as NPM and GitHub under what is known as an open source license. This open source license sets terms of use so other developers can reuse these components on other projects, meaning they do not need to repetitively code common functionality from scratch. They just need to code the functionality to bring all the components together. This is a huge benefit as it reduces the time to deliver a solution to market and at a lower cost. When developers take the code from repositories, this is how open source enters the software supply chain. And if those components have vulnerabilities associated with them, this is how those vulnerabilities reside in the final product. When components are not tracked as they enter the supply chain or throughout various stages of development, vulnerabilities like Log4j can easily be missed. One of the reasons Log4j has impacted so many organizations globally is because the majority had no idea they were using Log4j. By the time this had been ascertained, attacks had already taken place. The lack of visibility organizations had into their software and its dependencies catalyzed the impact of Log4j across the globe. Simply put, the dependencies are software components that another piece of software relies on. Dependencies are not actually found in the source code, but are pulled in at build time. These are what are known as direct dependencies. However, it is possible for these direct dependencies to have their own dependencies. These are called transitive dependencies. If each dependency in the chain has its own dependency, it's not very hard to imagine how large these chains may get. And this is why so many users had no idea they were running affected Log4j versions between the thousands of dependencies in their solutions. The fundamental aspect to quickly remediating risk in a Log4j type situation is to know exactly what's in your software. The best practice for this is the consistent production of a software bill of materials. You can see an example produced by the Revenera tool on the screen here. This is a formal record of components and their associated licenses in a piece of software. You can think of it like a list of ingredients on food packaging. An SBOM identifies and lists software components and their licenses and the security vulnerabilities associated with those components. A software composition analysis tool is the tool that will produce, one of its outputs will produce an SBOM. This will perform an automated source code scan to produce the software bill of materials, which will expressly identify all the third-party components in your software and tell you whether any security vulnerabilities are associated with them. An advanced software composition analysis tool will even tell you whether your code calls the affected library and suggest a fix. Once organizations have identified whether Log4j is in their code, the next step is to update and patch the vulnerability if they are affected. There are actually 4 vulnerabilities in relation to Log4j, though their CVE references are listed on the screen. This is because the first 3 patches failed to fix the vulnerability completely. However, all vulnerabilities at the moment are patched in the fixed in the version 2.17.1. This is the version that the Apache Foundation and security agencies and what we are also recommending our customers to advise organizations to update to. Thinking about the wider problem of software security, the important thing for customers to be doing moving forward is that they need to know exactly what is in their software and keep on top of updates. The sooner that you can implement the updates, the quicker the risk is remediated. And if you know what is in your software when another vulnerability like Log4j goes public, on the day of publication, you will have the ability to quickly identify if you are affected by that vulnerability and can make remediations accordingly. As vulnerabilities relating to software are on the rise, there have been a number of regulations issued by industry and governmental bodies to regulate the use of open source software. A regulation issued on the 12th of May 2021, which is now enforceable under US law, is the White House Executive Order on Improving the Nation's Cybersecurity. This executive order states buyers of software solutions should request a software bill of materials for each product, and a software solution provider should also supply a software bill of materials. The order also requires organizations to maintain accurate data provenance of software, of components, especially if these are open source. This means that it needs to be the origin of software components needs to be identified and tracked. Since issue, the regulation has created waves across the US as providers adjusted their processes to accommodate. This is also cascaded across global markets associated with US trade. Following the executive order, a bill has now been passed to address the state of the software supply chain. This requires contractors to submit to the Management Directorate of Department of Homeland Security, DHS, a bill of materials, a certification that each item in the bill of materials is free from certain security vulnerabilities, a notification of any identified vulnerabilities, and a plan to mitigate and resolve those identified vulnerabilities. When we think about standards and regulations, we often think about what sanctions are in place if we're not following them. And although the executive order expressly applies to organizations when they're dealing with US governmental departments, outside of that, there aren't any sanctions. However, what the executive order does is it mandates SBOM production, and this almost sets a best practice for organizations across global markets. They've set the bar for SBOM production as a best practice. Because of this, we may actually start to see organizations following suit, following the example that the US government has set. And this is something we've actually already started to see in the automotive industry. And if this is a best practice that's set, it's possible that this could then start creating barriers to markets if this is something organizations are following. When running a source code scan and producing a software bill of materials, this actually only represents your software at one point in time. This is the point in time that the scan was performed. And the nature of software development means that software composition changes on a day-to-day operational basis, as components in your software may change daily. The possibility of new security vulnerabilities entering your software supply chain may also occur on a day-to-day operational basis. Therefore, the management of these risks need to be a continuous process right the way through the development lifecycle. The best way to do this is to implement checks into all stages of development, starting with code development through to testing and the end production phase. This process allows an organization to fix the security issues as they appear, making the final build analysis, which takes place at the very end of the process before the product is shipped, a box-ticking exercise. Not only does this process increase an organization's component visibility and manage and reduce security risks, but it actually saves in time and resources. If a software project is designed, coded, tested, and then checks are made just before release, it is more costly in time and money to implement fixes at the end rather than catching and fixing bugs throughout the process. This process, by integrating SBOM processes and management of your software and software visibility, actually creates software which is secure by design. That has come, we've just about come to the end of my section. I've got some references on the screen here for best practices. The ISO 5230 Open Chain Standard is a standard for increasing license compliance across the software supply chain. This primarily does have a focus on open source software licensing at the moment, but we are seeing a growing focus on security in the software supply chain, and resources are being put in place by OpenChain to expand this standard. We have the Software Transparency Project made by the NTIA. This is the National Telecommunications and Information Administration. They advocate for software component transparency, and they were actually one of the main drivers behind the Software Bill of Materials concept in 2019, which the US government have now implemented. On their website, you can find resources and materials on the SBOM. All the links are included here on the slide, and we'll pass out the slides at the end of the session also. And finally, we have the Cyclone DX SBOM standard. This project is an effort to standardize SBOMs across the supply chain. It's a universal standard for SBOM production so that the exchange of data and materials across the supply chain is more efficient. You can also find some more information regarding this on their website. I believe.
Thank you, Holly.
Thanks, Martin.
We'll take questions at the end of the second part of the presentation as well. So now we've seen the situation and the issues at the beginning of the software supply chain. I'm going to hand over now to James from Block 64. So imagine you've now an end customer, you've adopted a solution, a software-based solution, and you want to know if any of those solutions are impacted by the Log4j issue. James is going to explain what they do as a business and also give you a demonstration of the tool that they've created for their customers to help manage the Log4j situation. So James, are you able to share your screen and take over?
Yeah, I'm going to take over now, and thank you for the introduction there. So nice to meet everyone. My name is James Lipinski. I work over here at Block 64. Essentially what we are is we're kind of an inventorying product. As a company, we have a focus on kind of the IT asset management side of things. And what that means for us on a security side of things is that when we're working with customers, they come to us and say, hey, I'm worried I have vulnerabilities, do I have antivirus? Do I have software vulnerabilities? Are there things like Log4j in my network? And the starting place for us is really to understand kind of what's actually in the network. A lot of customers know something about their network, but they don't know everything. And so the way we approach a lot of these vulnerability data sets is by coming up and understanding kind of what a comprehensive inventory of their network looks like. And to do that, we undergo kind of a network scanning process to pull back data. The first step for us is really to kind of understand what types of devices and software is in the network. So really, as we kind of go through the environment, we can pull back a list of kind of all the different devices there are. So are there Windows devices, Apple devices, Linux, SNMP? If it's there, we can find it and we can pull back that data. At a high level, when we inventory devices, we can kind of show a customer right away, hey, here's where your devices are. Here's what the device is called. Here's the type of device, Windows, Linux, SNMP, here's who manufactured the hardware, if it's a physical or virtual device, the OS, and the serial number assigned to it. Just kind of some high-level information, but what we're doing is pulling back distinct pieces of information on each device specifically. So beyond that, we can also see where it's hosted, who the user, the domain, the processing and RAM allocation, and importantly for Log4j and software vulnerabilities, a list of the software assets that are assigned to these devices. When we have an inventory of products and the actual software that's there, that now gives us the ability to kind of begin the initial analysis and really just kind of make sure we kind of know what's actually in scope for us to do the work going forward. The first step in a lot of these processes is just seeing the software we actually have installed. We can pull back a list of every software client in the customer's network. At the very beginning, we'll see kind of the actual most prevalent installations, and if we scroll down, we can see kind of who the publishers of these products are. We can aggregate the actual installation count based off the devices that are out there, and obviously from that, I can start doing some initial analysis. Are there products that I should be standardizing on that maybe I'm noticing a gap with? Well, if SCCM is a tool I want everywhere, I can identify obviously kind of where it's installed. If there's a gap of that, I can kind of do a bit of process elimination to identify kind of where there might be gaps. I can also go back and maybe search for things that shouldn't be there. Some customers are concerned with maybe file transfer tool sets. Dropbox is a common product where I'll hear, hey, I don't want that in my network. And if so, if we do see something like that, we can search for it. We can identify where the installations are. And obviously, when we see that type of information, again, can do kind of an initial analysis to kind of point out where there might be some gaps and something we have to go back and do the remediation on. A lot of this is, once I have the data, I can start doing kind of my own policy-based work. The other side of this for us is that because we are pulling back a lot of information on the software that's in the network, we can start to kind of point out where there might be some, the initial lookings of an issue going forward too. Cybersecurity, compliancy, all these different projects. There's a kind of a veil of mystery on them just because they're very, very complex. But if we can kind of simplify that down and kind of point out maybe initially by doing a first level analysis based off some of the data we're pulling back on the software side of things, that makes it a lot easier for us and our customers to kind of alleviate the issues we are discovering and making it a bit cleaner in their environment going forward as well. So for example, if I'm pulling back a list of software, very easily I can identify if there might be missing installations of antivirus, for example. I can see kind of all the different antivirus tool sets I have, and very simply just by looking at the list of software, I can also identify machines that do not have an antivirus installed on them too. Again, probably want an antivirus installation on my machines. I can identify that pretty quickly, and again, I can go back and start that cleanup process going forward as well. If there are further issues as well, I can even look at the actual software installations themselves, kind of run a CV score or run a comparison against known CV tickets in the net, from NIST, identify again if there are records of vulnerabilities here, and again, can kind of just based off the software, kind of point out where there might be some initial vulnerabilities and some initial issues for us. If we're seeing issues, obviously we want to go back and do that remediation, and if there's an opportunity to do that, again, we kind of have the list of devices right away, can point out where there's the risk, and kind of pull that list for the work going forward. With larger vulnerabilities like Log4j, Meltdown exposure, WannaCry Bad Rabbit, Bluekeep, when they were, or Proxy Logon 2, when they were first announced, a lot of our customers said, hey, we're worried about this specific vulnerability. Can you help us kind of point out where it might be? And so because we have lists of software and can identify kind of what's going on in the network, that gives us kind of the initial ability to kind of point out maybe where you might have some risk going forward as well. Really, the most robust way to scan and identify where you might have a risk for Log4j is to do kind of a deep disk scan on each one of your devices. Just the way our product works in terms of kind of scanning networks, a little bit resource intensive for us and a little bit resource intensive for the actual machines, and obviously a little invasive to do kind of a deep disk scan. So our goal is really to kind of provide kind of the first step for a lot of this. Just like we're doing with everything else, if we can kind of show you where there is something, you can kind of go and take kind of a deeper step or a deeper look into that as well. With Log4j, what we do is we pull back a list of all the known affected titles from the Cybersecurity Infrastructure Security Agency in the United States. When we have that, we can then start doing kind of a natural language comparison based off the actual software that's in your network. Essentially, I can compare the actual known vulnerable titles to the software that's there, and that's a way for us to point out what looks to be vulnerable and what might be a potential vulnerability in the network going forward too. Essentially, I can show you kind of that you have some Salesforce. Looks like there's a data loader installation that is known to be vulnerable. And if we look at the actual software that's in the network, Salesforce.com, data loader, it lines up pretty closely. Presumably, that's something I want to take a look at if I know there's a risk associated with that product. And really, we're kind of pointing in the right direction. And really, that's our goal here, is to kind of point customers and point out based off the information that's out there, so you can go back and kind of do that remediation. A lot of this and a lot of the goal here is that if we kind of know what's out there, we can kind of get those initial standpoint or get that kind of initial baseline for where we might be at risk, go back to that, and obviously from that kind of go back in and do a bit of remediation going forward as well. If we can identify risk, it's a way for us to kind of go back and clean things up. And the more we can kind of clean things up going forward, the faster it'll be for us to kind of obviously fix things up in the future and make sure we have kind of as clean an environment as possible. Obviously, we can do that for other reports too, things like WannaCry Bad Rabbit, just like I said for Log4j. But the key is that if we can find that data, can identify it, and obviously kind of remediate the risks going forward that way too. Again, if we can kind of find that, the easiest way for us to kind of fix it up is to kind of go through that process for that cleanup going forward afterwards too. So if we can find it, we can scan it. If we can scan it, we can kind of point out where that risk is going forward, so we don't have those issues as well. I think we're almost over time, so I wanted to go kind of quick there, but that's kind of what I had for today.
Thanks, James. Very interesting. It's good to see the user of software's perspective on Log4j, and actually there is a solution to help manage that. So I think we do have a couple of questions. So the first question actually is for Holly. Holly, from your perspective, are you saying it's down to developers to manage security related to Log4j?
No, what I would say is that developing security issues, not just Log4j, for all of them, it really should be a collaborative effort across a company. To spot issues as early as possible and to implement fixes, this needs to be a collaborative effort, even I would say across to managerial stakeholders in an organization. The presence of vulnerabilities and security issues presents significant business risk, and this is something management should be aware of and involved with.
Yeah, that makes sense. And also, is Log4j any different to other vulnerabilities that we've seen, such as Heartbleed, Apache struts, which affected Equifax, for instance?
Yeah.
Are they the same or are they different?
They're specifically, if we're talking about attributes and obviously instances when they came up, different. But if we compare if you were to compare media narratives for all of these vulnerabilities generally, you would see the same things, the same impacts, breaches that were occurring. And this Log4j, as I mentioned in the presentation, is not it's not the cause of a security issue. Really, it's a symptom of this wider issue about software visibility. We're seeing components come up, cause major impacts across the globe regarding security issues. And it's likely if we had those three you just mentioned there, which caused major impacts across the world globally, sitting in software systems, is likely that there could be some in the future. We don't know. So the best thing for organizations to be doing is have software visibility, know exactly what's in your software. So on the day that vulnerabilities like Heartbleed, like Apache struts, which is the vulnerability that caused the Equifax breach, on the day that they're publicly disclosed, an organization can go into work that day, know about that vulnerability, and having SBOMs, knowing what's in your software, may be the difference from patching and fixing that vulnerability in a matter of a couple of hours compared to, let's say, the better end of a week.
Sure. Thanks, Holly. Just one final question for James. James' question came in. How can you access your solution for Log4j? Is it a standalone product or is it part of your broader offering?
So it'd be part of our broader offering because we're kind of doing a network scan. Once we kind of pull back the data, we can do kind of that secondary analysis on top of it. So as we gather good data, we're able to also do that secondary Log4j analysis on it.
Excellent. So we're going to wrap up now. Thanks for your time. Thanks to James and Holly for great presentations. We have recorded this session and we'll distribute it along with a PDF of the slides. Look out for future webinars on our website and on LinkedIn.